Message display, view message, return as later.
So what? Lesson 14 group quiz. Yes. All right.
Oof. I will never forgive you.
All right.
Okay, start.
And so I know the answer to question number 3, guys.
Yeah, what it is?
True.
Why? ANOVA synthesis. Oh yeah, true. Oh, I need to have the number 1, number 2. Okay.
Yes, you do.
Number 4. What requirements need to check when performing a ANOVA?
ANOVA hypothesis test.
Hypothesis test.
There can't be any negative somethings. Let me see here.
This.
I'm pretty sure it's the first one.
Yeah, I know
everything you need to be positive. And
yep, I agree. The first one. Yeah, it says the values of f are never negative. It's right skewed, and the p-value for the ANOVA test is the area in the right tail when we use the applet.
no requirement. Data normal group. Data are normally distributed in each group. Yep. Data. Okay, the second one is true. And the third one.
So I think it's all 3 of them.
Yeah, the variance are equal for each group. Yep, all of them.
Wait, where are you?
What's that?
What number are you on?
4.
Okay, and you're saying it's all 3?
All 3 are, yeah.
But technically,
no, the variance.
In the textbook, it doesn't show. It says there are 2 requirements of ANOVA that must be checked. It just says number 1 is the data are normally distributed. Number 2 is the variances are equal. It doesn't say about being positive.
Okay, well, you know what has to be positive is the value of f. So.
Yeah.
Okay, so just the last 2?
Well, just the last 2 are like literally what it says for the 2 requirements are in the textbook. But the first one does make sense.
Well, I'm going to ask a really dumb question. Is the f value the sample means?
I think it's the same thing as like the t-score.
It is, which is the... So that is not... So that's not the sample means, right? Because what is always negative is never negative is the f value, the values of f.
I don't.
Okay, so I don't think it's the first one. I think it's the last two, like you said, Ryan.
Yeah.
And I think the answer to question 5 is construct a QQ plot for each group to check if they're normally distributed.
Yeah.
Because that's what the instructor said in the videos.
Yeah, it's a QQ.
Okay.
Are you in anatomy? Which one? The 464 or the
Sweet.
Yeah, not right now. You can go on. Well, actually, 460.
Is it the second one for question 6?
It's just anatomy. But it's like, I think it's mainly for biomajors.
I don't think so.
If the variant predictors is the same, if the value. So equal force and it's requiring an equal.
Mm-hmm.
Oh, okay.
Well, I know that you have to check things with the smallest mean is less than, the largest variance is less than 4 times the smallest variance.
Yeah, I need to be small.
But
the larger variance is then or equal to 4 times smaller the variance. So that means the second option from number 6. So if the larger variance is less than or equal 4 times of the smaller variance, then we will conclude that the variance are equal. So yep, the second one.
Okay.
Number 7.
an ANOVA hypothesis test is equivalent to conducting independent 2 t-samples between every pair of samples. If there are 3 samples, there are 3 pairs. How many pairs are there when there are 4 samples?
One and two, 1 and 3, 2. So 1 and 1, 1 and 3, 1 and 4, 201, 203, 24, 31, 32, 34, 41, 42, and 43. They are 12? Am I right? Or am I wrong?
So she said actually might be more like 6.
I must have missed this part of the lesson.
Let's see, we have only 1 and 2 and 1 and 3. Yeah. Looks. If that. No. If there are 3 examples, there are 3 pairs.
I only got 1, 2, 3, 4, 5. I got 6, but that doesn't mean I'm right. 1 and 2, 1 and 3, 1 and 4, 2 and 3, 2 and 4, 3 and 4.
Oh, okay.
But I don't know. I missed this part, evidently. What do you think, Ryan?
2 and 1.
I'm not sure.
2 and 3.
1, 2.
3 and 1. And 3 and 2. Oh, okay, I get it.
Well, that makes sense. Yeah.
1, 2, 3. Because 2 and, for example, 2 and 1 and 2, 1 and 2 and 2 and 1 are the same thing. So, okay, I eliminate those one. 1 and 2. So, then 4 and 1 and 8. 2 and 3. Yep. One, two, three, six.
Did you still get 12 or did you get 6?
I get 6.
Okay. Do you agree, Ryan?
Yeah, I think it's 6.
Okay. All right, guys, we need the soccer shoes file.
I thought you want my soccer shoes. What are you talking about?
I know, that's why I figured I better put file after it.
Okay, soccer shoes opening. La 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 la. Where is Kira? Is she in the movie theater now?
She must be. I don't know, I've texted her twice.
She don't even gotta go nowhere. She can just sit on her little chair, her pull-out chair.
experience running, sure.
She has like 2 more years.
Okay, give me my file. Okay. There are 120 items, I believe.
Okay, we need to know what is the minimum, the smallest variance for the 6 groups.
Okay. So I need to look how to do that.
Okay, so the first thing you do you want me to tell you how to do the different steps to everything?
Sure, why not?
Okay, so you got the file in SPSS?
Yes, it's open already, and
Okay,
there are
so-
120 items.
So go to Graphs,
Graph, yeah.
Legacy Dialogues,
Legacy,
Histogram.
I know.
Mm-hmm.
Now, in the first box, put whatever column has the numbers in it.
The numbers.
Are there numbers in one of the boxes, one of the rows?
Because you have bookwares, it's A, it's letter, and accuracy is the numbers.
Okay, put accuracy in the variable box.
Okay.
In the second box, put the conditions or what the groups are, like the names of the shoes.
Okay.
And then hit OK and continue.
Okay. So first one, the variables accuracy is the number, so I put that one in the first box, right?
Yep.
And then in this, it only showed me one.
I already made a login from last time, so I don't have to make a login.
Let
Does
me.
it show you a box that there's like a rows box and a columns box?
Yes.
So in the rows box, put the condition or the group, the name, whatever the shoe names are.
Okay. And then I put OK.
Yep.
There we go. Processing.
Got it?
Yeah. I will.
Okay, now
I will share this.
Oh.
And that way you can see what's going on too. What is the? There we go.
Ryan, how are you doing?
So I was able to get the descriptive information up. So I've got all of the groups, the mean, the median, standard deviations of them. What are we looking for again?
Okay,
Do you see me?
I do. I got it, but we've got to do more, Kenny.
Okay. Sorry.
No, that's okay. That's just the first step. And Ryan, the first thing we need is what's the minimum or smallest variance for the 6 groups?
Mm-hmm.
You have that?
Let me check.
Okay. Kenny, you want to do the next step?
Sure.
It's called, now we have to recode because SPS can't read the column that has the letters in it, so we have to recode those.
Okay.
So hit transform,
Okay.
automatic recoding,
Okay.
okay, and then move whatever column is labeled that has the words in it, you know, the shoe, the different shoes.
Uh-huh.
Move that to the variable box.
Okay.
And then under it, you have to rename it. You can just name it, recode it, or whatever. You name it whatever you want.
Recode. Okay.
And then hit OK.
Add a new name. Okay.
And then, do you see there's another column that has just numbers in it?
Let me see. Oh yeah.
Okay.
What do I do with those numbers?
Nothing right this minute. Okay, now go to Explore.
Explore.
Uh-huh. Oh, never mind. This is what we're going to do. We're going to explore. Go to Analyze.
Okay, that was like, what?
Sorry.
Analyze.
Descriptive Statistics. Up. Way up.
I click. Oh, yep.
Yep. Explore.
There we go. Explore it.
And then put the statistic, the number column, so the accuracy column over independent list.
Accuracy, independent list. Uh-huh.
Yep. Take the recode and put that in the factor list.
Recode and the factor list.
You got it.
Mm-hmm.
Go to plots.
Plus.
Over to the right there, those blue boxes. Yep.
Uh-huh.
Hit histogram.
Histogram, okay.
And then go down and hit normality plots with tests. Up, right there. Up. There.
Okay.
Continue.
Continue.
Okay.
Yes.
Okay, one more thing.
Okay.
Go to Analyze.
At
At the top.
Analyze.
You got it. Compare means
Mm-hmm.
one-way ANOVA at the very bottom.
Ooh.
Okay, I've got the answers.
Oh, look at you! Dependent list. Put the numbers, the recode
The,
thing.
the
Oh wait,
recode,
no. Put the. Where's your accuracy thing?
the accuracy is kicking accuracy.
Oh, okay. Yeah, put that over there in the dependent list.
Mm-hmm.
And then the recode in the factor. In the options box over, yep. Hit descriptive, means plot, continue and OK. Voila, fish and chips. You got it all done, Kenny.
Sweet. And I had a video. I will learn more.
All right. So, Ryan, what's the minimum, the smallest variance?
So the smallest variance was in group number, it was C, and it was 27.208.
Well, I need to come back to the other place.
Yep.
And then for number 9,
Uh-huh.
the maximum variance, the biggest one, was in group D, and it was 53.158.
53.158. And what was the minimum?
It was, let me go back.
27.208.
27.028?
No, 0.208.
0.028?
Nope. 0.208.
Oh, okay. I'm sorry.
Okay.
Man,
Is
and
that
I
right,
was
Ryan?
Yeah, it's 0.208.
and I was a customer service in the phone, so yeah.
Okay. The test for equal variances is satisfied for this data.
Let's see this thingy.
I would say yes. What do you think? True. And this is what I'm basing that off of, and I don't know if it's right. I divided 53.158 by 27.208, and it is less than 4.
Mm-hmm.
So that's
Yes,
why I said true.
That is correct.
Okay. So you two have the Q plots, the QQ plots.
So it was true. Okay.
Okay. Yeah. Are they approximately normal?
Okay, let me see. Q-box, where are you? One way.
There should be 6 of them.
Okay. So for A, it is normal. For B, it's almost normal. For C, it's basically normal. For D, it's basically normal. For socks, basically normal. A little bit off, but it's... So I think they're all pretty normal.
Okay. So we'll say true.
Yeah. Yeah, because they're approximately normal.
Okay. Okay. So it says perform an ANOVA test in SPSS and observe the p-value is 0.081. Holy cow. Can you guys do this? Number 12?
Let's see.
So we need to take socks.
You have to remove the SOX data and perform the test again.
So I only erase it. That's kidding.
I don't really know.
So no socks.
While you guys are figuring that out, I did figure out the answer to number 13.
Ooh.
It's easy. It's right.
Sweet. Let's see.
No, I'm saying you need to send it to me.
How you guys doing with number 12?
I can't find the p-value anywhere. I have a stand.
Let me see. The p-value is you take, oh, just a second. Let me see.
I have the standard deviation.
The p-value is the box that says SIG. It's next to the degrees of freedom.
You probably got the emails.
I think I need to redo it. Let's see.
How are you doing, Kenny?
Well, I need to figure out what is that box. SIG, that's the one that we are looking for.
We're looking for.
Oh, SIG. Okay.
Well, that's the SIG is the. Oh, what I just say? That's the p-value. But for question number 12, yeah, we have to have the.
Take this off.
Yeah, remove SOX data and perform the test again. And what is the p-value? Okay, so the p-value for the whole thing is 0.081. Can you guys find that on all that stuff you did?
So I just deleted it and took it out. But I put in the numbers and it came out as 0.309. Does that make sense?
Makes sense to me.
Is SIG?
Yeah. Is the degrees of freedom next to it?
Yeah.
Let's see. Degrees of freedom says. Which one do you want, between the groups?
No,
within the
I
groups?
don't. We don't need it. I just wanted to make sure you were in the right place, you know, because you were questioning it. So if it's the box that says SIG and it's by the degrees of freedom, you've got the right box. So you should be good.
It's not by the degrees of freedom, it's by the F score.
Okay, it's all in the same area though, right?
Yeah. Oh, yeah.
Yep, you're good. You're good. And then the test statistics for ANOVA hypothesis test is an F statistic, is the p-value of the area to the right or left of the F statistic. And it's to the right because they're right skewed.
Mm-hmm.
Makes sense?
Yes. Hot dog.
Okay.
Let's examine the calories.
Oh,
Construct
so,
QQ.
oh, I thought you were saying hot dog. Now I get, duh.
Oh,
I thought,
now I'm moving on to the next one. Dude, you're gonna make me cry. Oh my gosh, did it die? Let's see, adenine glucose, type.
Fueron a MOVA test en SPS. Set the p-values.
Okay,
Oh, okay.
go back to this. Go to export.
I think might be what I was in my case.
You need me to read the steps, or are you good?
No, because the p-value should be 0.081, right?
That's with everything together.
Everything together.
The type. Okay, and then I'm going to analyze. One way ANOVA. So now descriptive lines plot.
You guys need me to help with any, not that I can help with much.
I have the descriptive statistics, but I don't have the QQ plots. I have everything else. Do I need the QQ plots technically, or should I just use the variances and see?
Let me see, do we need QQ plots this time? Yeah.
Okay.
Oh, wait. Yeah, I guess. Yeah, we need them.
Try to whip it out.
Yeah, because the first thing is, let's examine the calories first. Construct QQ plots of the calories for each of the 3 types of hot dogs and compare the variances to determine if the assumption to use ANOVA has been met.
Okay.
I had no clue
No clue what?
to take the salts. And do the analysis. Analyze.
Hmm. So I did get a QQ plot, but it's only one. It's not of like each of them, but they all follow the line pretty closely.
Oh, so it's all of them on one QQ plot?
Yeah, is that okay?
I don't know why it wouldn't be, but I think that's okay.
Okay. Yeah, they're all pretty similar.
Okay, so it says here, let's examine the calories first. Construct QQ plots of the calories for each of the 3 types of hot dogs and compare the variances to determine the assumption to use ANOVA has been met. So the answer, well, you can read the answers. I guess I don't have to read them to you. But the assumptions have been met. It's safe to assume each group comes from a normally distributed population from the QQ plots. And we can also assume that the variances are equal.
I think so.
So are the variances are equal, or it's been met while it is safe to assume each group comes from a normally distributed population, we cannot assume that the variances are equal? Don't you have the variances there?
I don't think it shows the variances. So maybe, because I think I remember watching the video that you can't determine it just from looking at the plot. You actually have to like do the math and the numbers of the variances. So I'm guessing that it could be the second one.
Okay, because the QQ plots are pretty close to normal, you said?
Mm-hmm.
Okay. What do you think, Kenny? Do you agree?
Yeah, I mean, it makes sense, but
Okay, now it says run an ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. You should find that the degrees of freedom are 2 and 51, that F is 16.074, and that P is 0.000. What conclusion can you draw?
so we had the degree of freedom with a FMP.
So, did you guys do you guys have, are one of those tests that you did, or one of the statistics have the mean number of calories?
And which one, in hot dogs?
Yes. Uh-huh.
Hmm.
Okay, I think I got it.
Cool.
Let's see. So wouldn't it be D?
You guys, I sent you, Brian, it sounds like you know what you're doing, but I typed out the how to do this stuff in SPSS for ANOVA, so I just sent that to you guys. So for 15, I don't know what you found. What are the means? Is it the same for all three types of hot dogs?
I would not say that. I would say that it is D because the p-value is less than the level of confidence interval. Because
Okay.
I think in order to prove it, the p-value needs to be lower than 0.05, but it doesn't prove which one, it just proves that one of them is different.
Uh-huh. Okay, that's cool. I agree.
Okay.
So it was what? Sorry.
The last one?
Okay. And before that one, 14, it was A, B, C, or D?
B.
Okay. Okay, I got that one right.
Okay,
I
it says
wasn't sure.
now let's examine the sodium levels. Let me ask you this, guys. Do you already have the sodium level stuff there, or do you have to go back in and do all this again for the sodium level?
Let's see.
Let's see.
Wait, it's talking about the QQ plots, right?
Right. Now let's examine the sodium levels. Construct QQ plots of the sodium level for each of the three types of hot dogs. You should see that the QQ plot for poultry suggests a possible problem with the normality assumption. The smallest variance is 7180.75, and the largest variance is 10492.871. Have the assumptions been met to use ANOVA?
Control Q plots for HLC. Okay.
Pero usted no lo estaba cerrando, lo estaba abriendo.
¿Lo cerraste?
Podía abrirlo, lo hacía para todos lados.
Este lado está bien. Esto siempre lo abierto.
Ah, pues entonces.
Este no va.
Ah,
O sea que
no, ya te iba a llamar.
Oye, ahorita la...
Sí, 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 sí.
The one doesn't, it's not a normal KQ plot?
Wait, I'm trying. Let's see. Explore.
¿Vas a la piña?
No,
No.
Just sodium.
me trajo como que voy a servir el viernes.
Ho, 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 ho.
Ay. Ay.
Plots.
Sorry guys, I have my cousin coming. She didn't know how to open the door. Anyway. Are we still in number 16?
Yes.
Okay.
Okay, I think I got it.
Okay.
So for beef, it looks normal. For meat, it looks pretty normal. And for sodium, looks a little bit less normal, but it's still kind of following it.
For poultry?
Oh yeah, sorry.
That's okay.
Poultry.
Salt, poultry, yeah, all the same. Do you, so if you divide the smallest variance into the largest, it's less than 4.
Let's see if it includes variance. Okay, let me write down the variances then. The variance of sodium is 10,492.
0.871,
Yes.
right?
0.871.
And then the smallest variance is 7180.75.
Yes. So which one would we put for 16?
Yeah, I don't know, I'm confused on this one.
I think we can assume the variances are all equal.
Okay. So then, can we assume the variances are equal then?
Yeah, I believe we can assume the variances are equal.
Because we can divide that number out and have it be less than 4?
Mm-hmm.
Okay. So it would be the first one then, right?
I believe so.
Okay. And then it says, despite the possible problem with the QQ plot for poultry, you decide to use ANOVA to determine if the mean sodium levels are the same for all groups. What is the p-value for this test?
For the poultry?
What did I miss? I'm sorry.
Question number 16 is the first one. And we're working
Okay.
on 17 now. It's my little drawing here. So, what are we looking for? The p-value. Okay, so Ryan, in that box that has the degrees of freedom and the F value,
Mm-hmm.
so the top line is the variation among the sample means, and the second line is the variation among individuals in the sample size. What's the F score in those? Is it the same?
Wait, so I'm looking at sodium, and it says test of normality. There are two different groups. One of them says Kolmogorov, and the other one says Shapiro, and they both have like statistics, DF, SIG, and that, like, it basically repeats itself, but they're different numbers. So which one would I do, the left or the right?
I'm sorry. Are they both sodium?
Yes.
So it didn't like do them together.
That's so strange.
Yeah. Well, what's the F value for the two?
Oh, it doesn't even show that. Huh. I might just go back and try it again. Let's see.
Okay. Ooh, it's raining. Just a second. Good grief.
Okay. Now we are doing it with sodium, right?
Yes.
Okay, because I just finished the other one. Okay, let's do with sodium. Do I need to open again, or can I do it with the file that I have? I got a warning.
You have to ask Ryan that one, because I'm not.
I did ANOVA, but I did it for both calories and sodium. But could I just use the one that says sodium?
Yes. Mm-hmm.
Okay.
Okay, I will do that.
It says the p-value is 0.179.
Okay.
That's the SIG.
0.179. Perfect.
0.179.
Okay. So, what conclusion can you draw about the mean sodium levels of the three types of hot dogs? Use a level of significance of 0.05. So,
What was the number for 17? And see if I got the number.
0.179.
0.17. Yeah. Sweet. Okay.
Oh, goodness. Okay, so
¿Grabando?
if the p-value is less than the level of significance, you do not reject. Don't reject. Well, I can't write. Jeez. So is 0.179 less than 0.05?
No.
Reject. So reject the null hypothesis if the p-value is less than the level of significance.
So
If
we
not,
can't,
don't
yeah.
reject. Oh, now I get
But
it.
we do not have sufficient evidence to reject.
Right.
So I think that's B.
Okay.
Oh, wait. We have sufficient evidence to. Wait.
No, it's greater than 0.05.
Okay. Oh, gotcha. Okay. Cool. So, shall we hit submit?
Let's do it.
Oh, wait.
Oh, what?
I missed 12.
Oops, I just submitted it. Oh, man, guys, we did good. We got 90.
Wow.
Okay, so number 12 is 0.309.
Which ones did we miss?
309.
Is number 12. So we
Okay.
missed number 14 and number 16. So I will tell you this. The answer to 14 is not B. And the answer to 16 is not A. Oh, we need more practice in those areas, guys.
Okay.
Wait.
Okay. Sweet. I did not change anything. I sent it like it was.